All right, welcome everybody. Let's do this. Lesson number 4. So before we actually get into the worksheet of lesson number 4, we're gonna have a little pre-lesson. So just to get the basics of trigonometry. So, what is trigonometry exactly? Trigonometry is the branch of mathematics dealing with the relations of sides and angles of triangles. So we're going to be studying triangles within trigonometry. Okay. So to start things off, let's have this in our notes. First, the definition of trig. Second, rotation within trigonometry. So by now we should be okay with having our circle over here, and here are the degrees: 0, 90, 180, 270. Now there are certain terminology we need to be okay with. First is initial ray, okay? And let's move on. What is the initial ray? Let me fix my camera angle. And please, what I want you to do is have this in your notes before we actually begin, okay? So take a second, pause the video, and have this within your notes, okay? So here we have the initial ray, right? So what is the initial ray? It is the starting point at 0 degrees rotation. So anytime we want to rotate, whether it's positive or negative, we say that at 0 degrees at the 3 o'clock position, this is the initial ray. This is where we start. Now, the terminal ray is where our rotation ends. So let's say we wanted to rotate, I don't know, like 30 degrees. Well, okay, well, we start over here as the initial ray. I could go 30 degrees, and then what we're going to call this at the end of the 30 degrees, we're going to call this the terminal ray. So we'll have this over here, terminal ray. Okay, now what's the next notation? It's this symbol of theta. What is theta? Theta is our angle of rotation. So here, if I rotate 30 degrees, we're going to say that this 30-degree rotation is theta. So here, theta is equal to 30 degrees, right? We're just saying we're rotating this much. Now, phi is the reference angle. And what the reference angle is, we're going to get to that right now. So what I'd like you to do is have this in your notes as well. So what is the reference angle and how does it help us? Okay, because this idea will be very, very, very important. So the reference angle, it's this definition here. But first, let's have this down. Okay, how to calculate the reference angle and why it will be important will be for the next lesson. How to find the reference angle is what we're going to do for today. So the reference angle is the angle in between the terminal ray and the x-axis. Okay, so pause the video, have this down in your notes, and we'll begin with this part of the lesson. Okay, so for the first part, let's see. It says, let's have this in our notes. Let me take this paper away as well. Okay, this looks good. Here it says rotate and find the reference angle for 42 degrees. So what's the first thing we're gonna do? Step number 1, we need to have the initial ray, right? Where is the initial ray? The initial ray will be in the beginning. So first, let's just kind of have this over here. Okay, now there's our initial ray. Now, what is our terminal ray? Over here, our terminal ray is 42 degrees. So all we're gonna do is rotate 42 degrees, but where will 42 degrees be? And which one of these quadrants? Very simply, it's in quadrant 1 because 42 is in between 0 and 90. So where is 42? Let's say somewhere over here, okay? And now, what do we need to do? Let's just go through the steps. So step number 1, put a point on the intersection of the terminal ray and the unit circle. So notice that this is the terminal ray and this is the unit circle. And what the unit circle is, we'll discuss that in the next lesson. But here, we're gonna put a point on the intersection. So where is the intersection of the terminal ray and the circle? It's right over here, okay? Now what's the next move we're gonna do? It says draw a line from the point down or up to the x-axis. So here, where is the x-axis? It's over here. All we're going to do is draw a line from the point to the x-axis, okay? And now it's saying use algebra to find phi, or the reference angle. But what is the reference angle? It is the angle in between the terminal ray and the x-axis. So what is the angle in between this terminal ray and x-axis? It's right over here. And notice it's simply 42 degrees, because 42 degrees is the angle in between. So notice that your theta was 42 and your phi was also 42 degrees, okay? So just bear with me, okay? I know that was very straightforward and very easy. Let's try and do another example, okay? Here, let's rotate and find the reference angle for 130 degrees, okay? So let's see how this is a little bit different. So first, what's the first move? Let's make the initial ray, right? The initial ray is over here, okay? Now we want to rotate 130 degrees. Where will 130 degrees be, and which one of these quadrants? It should be in quadrant 2, because 130 is between 90 and 180. So where is 130? Give or take, it should be something like this, okay? So notice that this is our terminal ray, okay? Now here, what is our theta? Our theta is the degree of rotation. So notice our theta is 130 degrees. But now what's the next question we want to figure out? What is the reference angle? What is the phi? So let's just take a look again. The reference angle is the angle in between the terminal ray and the x-axis. So what's in between this terminal ray and x-axis? It's this angle over here, and we're going to call that phi, okay? So now, what is this angle? How do you know what this angle is? Okay, and this is 130 degrees rotation from here to here. How would you know what this degree has to be? And I want you to pause the video, think about it, and let's see what you got. Okay. First, we forgot this first step, right? So here we made our triangle. What is this angle here? This angle phi should be 50 degrees. And why is it 50 degrees? You know, if you have a straight line, what is the measurement for an angle of a straight line? It's 180 degrees. So if I were to have a straight line, and let's say this rotation was 100 degrees, what does this rotation over here have to be? It has to be 80 degrees, okay? So notice, what did we do? We just found, well, I guess the math behind it is we did 180 minus theta. 180 minus theta, because here, what was our theta? It was 130, so 180 minus 130 is 50. And here we go. Let's put a better smiley face. So this was 50 degrees. Okie dokie. Let's try the next one. Here, let's see how clever you are. And everybody, I want you to try this. Pause the video, copy this down. You can do this. Here, rotate and find the reference angle for 210 degrees. Okay, let's see what you got. So, pause the video and try and do it. Here, if you want to see how it's done, let's look at the first move. First move, let's draw our initial ray. And now, where will the terminal ray be? Reference angle 210. Which quadrant will it be in? It will be in quadrant 3, because 210 is between 180 and 270. So where is 210? Give or take, let's say we do the rotation, right? We go all the way. I can't bend my hand that much backwards, but it should be somewhere here, okay? So notice that this rotation from here to here, because you started at 0 and now you're at 210 over here, this rotation is 210 degrees, okay? Now, let's do the first move. What does the first move say? It says put a point on the intersection of the terminal ray and the unit circle. So here, let's put a point here. And now notice we make our triangle. We are making a triangle here, right? Now, we draw a line from the point upward down to the x-axis. Okay, so we did that. Now we need to find the reference angle. If you know this is 210, what is this angle in between the terminal ray and the x-axis? Here, this phi, let's see how clever you are. This phi should be 30 degrees. Now, why is it 30 degrees? You know that, let's say if we just have, let's say if we just have this here, right? Let's just focus on this part here. Notice that if this is 180 and this is 210, what is in between 180 and 210? What is in between 180 and 210? It has to be 30. It has to be 30 to get from here to here. Okay? So how could you think of that? You could also think of it as the terminal ray minus 180 degrees if you're in quadrant 3. Okay? And this is like a cheat. I don't want you to really use this, but you could do that. Imagine, you see, what's the terminal ray? It was 210 minus 180. But then if you're thinking, oh, mister, how did we do it before? Here, when you were in quadrant 2, it was a little different. We did 180 minus theta. When you're in quadrant 3, you're doing something a little bit different. It's the terminal ray minus 180. Now let's try this one over here. Rotate and find the reference angle for 300 degrees, okay? Pause the video and try and do this by yourself. So here, what's the first move? Okay, we have our initial ray, and then we're going to rotate 300 degrees. So where is 300 degrees? Which quadrant will it be in? It should be in quadrant 4, because 300 is between 270 and 360. So 300, give or take, should be here. Okay, and what was the rotation? We started from here and we went all the way around. Okay, now what is the phi? What is the reference angle? Well, let's follow our moves first. What's the first move? Put a point on the intersection of the terminal ray and the unit circle. Okay, let's do that. And then what do? We draw a line down. Now the question is, what is the angle in between the terminal ray and the x-axis? What is this phi over here? So let's see how clever you are. Notice that the rotation was 300 degrees. So the question you should ask yourself is, what's in between 360 and 300? How much is in between over here? This phi should be 60 degrees. That should be the reference angle. Okay? And how were we able to do it over here in quadrant 4? You could just do, why don't you think about what the formula would be for quadrant 4? Okay, pause the video. But if you want to see it, it should be 360 degrees minus the terminal ray. And here, the terminal ray, you see, was 300. So we just did 360 minus 300. Okay, what I want you to do is, hopefully today wasn't too bad, delta math. Here, delta math has some really nice problems to practice this on your own, okay? And for the next lesson, we're gonna actually learn about sine, cosine, tangent, and what these mean and how can we study the relationships. Happy face. Enjoy your day. Work on your delta math.